Previously, on Free Return Trajectory, numerous dust devils have formed in a specific area on Mars, and these dust devils appear to be converging on a specific small area on Mars. A month after MOM detected the mass con, it was clear that something very recently changed on the Gale Crater, and that's when the strange event started happening. Contact with the rest of the orbiters around Mars were also lost. Curiosity, Perseverance, and even Insight could not detect MRO, or any of the orbiters for that matter. What is the safest way we can use these four hardware to monitor the Gale Crater event as it unfolds? The deepest part of the Mariana Trench on Earth is about 11 kilometers from the surface. Here we are, in a global ocean on Enceladus. The depth of this ocean is unknown. Our point of entry into this ocean was above a 5-kilometer deep plateau. This allowed us to set up a temporary camp at that depth. With our initial mission completed, we are now heading to a new location 100 kilometers south from our entry point. The plateau is now behind us and we have no idea how deep the ocean floor is. Carl, our research vessel, is rated to a depth of 25 kilometers. We've decided to drop down to a depth of 20 kilometers and instantly surpass the depth record of all explorers on Earth. But that's not the real motivation for us going deeper into the ocean of Enceladus. We are trying to get to warmer waters, which we suspect will be near the ocean floor, driven by hydrothermal vents. Where there's warm water, there's energy. Where there's energy, there's a chance that more complex molecules can be assembled and more complex processes can be driven. Molecular processes so complex, we just might call it life. Discovering these processes, if there are any, will take some time. This gives me time to get back to the story of our rapid colonization of the solar system. It's been over 3 months since Insight detected the phantom meteorite impact that left no impact crater. Since then, it seems like Mars has become active in some strange way. From the 200-kilometer dust devil tracks to the loss of most of our orbiting spacecraft around Mars. But even before the phantom meteorite impact, NASA, using the Mars Reconnaissance Orbiter, noted a 36% reduction in mass of a comet called P2019 LD2 at its nearest approach to Mars. The missing mass was never accounted for. There is a term that was used in the early days of Mars exploration to describe the high failure rate of missions to explore Mars. The Mars Curse, it's called. The loss of 7 orbiters in 7 days had some people believing that the Mars Curse was back, but NASA still had functioning hardware on the surface of Mars, and it included the 2 nuclear-powered rovers, Curiosity and Perseverance. They were the most advanced rovers on Mars at that time. Because of their mobility, these rovers became the primary contact point between Earth and Mars. They gave NASA the ability to still perform analysis of the surface of Mars at many locations. However, with the ability to view Mars from orbit lost, NASA now had to solely rely on terrain data that was previously collected to help navigate the rovers. This is not really a problem since the rovers have enough sensors and AI power to navigate on Mars for short distances autonomously. Perseverance has 6 sensors for navigation alone. But what the AI doesn't have is the ability to avoid approaching dust devils. Dust devils are extremely weak on Mars when it comes to pushing big things. So there is no danger that the rover will be flipped over, unlike some science fiction movies from the early 21st century. This is real life. The danger is a lot of dust being blown around the rovers. Short exposure to a dust devil is not dangerous to the rover, and in many cases, it's helpful in cleaning solar panels by blowing away accumulated dust on horizontal surfaces. But prolonged exposure to many dust devils, especially ones that are 500 meters or more in diameter, can be dangerous because of the massive accumulation of dust around the rover. Even though the two rovers are nuclear powered and are designed to prevent dust from getting into their mechanical joints, accumulated dust on the rover can still affect many things. It can interfere with the accuracy of sensors, prevent mechanical actuators from functioning properly, and even affect the efficiency rate at which electricity is generated by the RTG. More on the RTG later. Since these new dust devils are all originating from Gale Crater, NASA determined that they must be driven in whole or in part by different processes than the normal dust devils, a process that could impact additional properties onto the dust devil itself that was not tested for on Earth. With the loss of the orbiters overhead, it would be impossible to get updated images of the area surrounding the rovers. And with visibility approaching zero, the only thing NASA could do is stop all the rovers from moving and protect Ingenuity, potentially the only eye in the sky for Earth. At least, until CNSA thinks it's safe to lower the Tianwen-1 into low Mars orbit. By the looks of the 7 orbiters lost in 7 days, it won't be anytime soon. Perseverance was moved over Ingenuity to give it some protection from the dozens or so dust devils that were now headed its way. Curiosity, Perseverance, and Insight then went into a partial sleep mode. In sleep mode, all camera dust covers are closed, arms are retracted, and cameras are powered down, among other things. By now, the countless dust devils have grown and merged to what was starting to look like a global dust storm. NASA was confident that Curiosity and Perseverance won't meet the same fate as Opportunity, which was lost in a global dust storm due to the solar panels being covered by dust in 2018. Curiosity and Perseverance both run on a multi-mission radioisotope thermoelectric generator, or simply RTG. These RTGs generate 110 watts of power. Heat is generated from the decay of a plutonium-238 fuel. The heat from the RTG and the cold air from the Martian atmosphere are then applied to a thermocouple device, which converts the temperature difference into electricity. This difference in temperature that is required to generate the electricity is why accumulated dust on the RTG can affect power output. The dust will act like an insulator between the plutonium core and the cold air, thereby decreasing the temperature difference, which in turn decreases the electrical output. As for Insight, it depends on solar cells to generate electricity, so it might not make it through the dust devil storm. With all of its assets on Mars in sleep mode, NASA waited for the storm to subside. But just after 2 days of being in the storm, Perseverance was lost. It was unclear what went wrong. Electrical, communication, and power failure are all possibilities, although power failure is highly unlikely. Ingenuity was also presumed to be lost since it uses Perseverance as a relay to communicate with Earth. Insight was still functioning, sending data to Earth. A string of quakes were detected by Insight coming from Aeolis Mons. Each quake, starting from the rim of Gale Crater, appeared to come from a lower elevation than the previous one. By the 9th quake, they appeared to be coming from below the floor of Gale Crater. 5 days after the dust devil storm started, Insight stopped sending data to Earth. This was expected because shortly after the dust devil storm started, the solar panels were generating less and less power each day, an indication that they were being covered by dust. So it was just a matter of time before the level dropped below what was necessary for the direct-to-Earth X-band transponder to function. Although Curiosity was communicating with Earth, it was only doing so as a means of staying in communication. Curiosity has the Rover Environmental Monitoring Station, or REMS. It measures the temperature, wind speed, humidity, and UV levels around the rover. Even though the rover was in sleep mode, REMS was still collecting data and relaying it to Earth at a slow but regular interval. Finally, after 14 weeks, the dust devil storm came to an end, as reported by REMS. At the end of all of it, all Earth had was a single hardware that could give a detailed report on the Gale Crater event. That hardware was Curiosity. Back on Earth, the Gale Crater event wasn't seen as a big deal by the general public because it didn't seem that way. The loss of all orbiters around Mars had almost no effect on the lives of people on Earth. Some people even use this loss as an example of how space exploration is a waste of money and that there are no benefits for continuing it. Earth had its own set of issues with the spacecraft in its orbit, better global internet coverage being one of these issues. But in the halls and offices of every space agency, the atmosphere was very different. 7 orbiters, 1 rover, and a lander, hundreds of huge dust devils originating from a single point and moving up crater walls. Scientists within these agencies were starting to think that they might be witnessing a planet-changing event. There was a fierce debate at NASA about what to do with Curiosity: continue with normal operation, or drive directly to Aeolis Mons and analyze the soil and environments. This might shed light on what happened to the meteorite and even give us a clue on the composition of the mass con under the crater. Since Aeolis Mons might hold the key to the most important event in the history of studying Mars, or even human history, and also be a potential safety hazard for upcoming missions to Mars, NASA decided that the best thing to do is to get Curiosity as close as possible to Aeolis Mons in the next 12 months. A few months before the next wave of spacecraft are launched. No stops will be made along the way unless an anomaly was detected. After the 12 months, Curiosity would then start doing intense analysis of the surrounding area. And with that, Curiosity began its 12-month journey. Aeolis Mons is a 5.5 kilometer high mountain at the center of Gale Crater and was the official destination of Curiosity. But due to the Gale Crater event, Curiosity was directed to take the most direct path possible without stopping for research unless absolutely necessary. Aeolis Mons is about 50 kilometers away. The terrain in between is rough with many steep slopes. Driving a rover on Mars is very tricky. Actually, it's impossible because of the delay of the control signal by at least 12.5 minutes due to the distance between Mars and Earth. This single issue creates a host of problems when it comes to operating a rover. Actions that the rovers should take are batched up and sent to the rover, because some actions would inevitably fail and the outcome of others are not known until they execute. The list of actions can't be too long since assumptions made before execution may no longer be valid after the data is received on Earth. The top speed of Curiosity is 90 meters per hour, but in actual operation, it averages only 30 meters per day. At that rate, it would take about 5 years to reach Aeolis Mons. But the goal of the current mission was not about the time it takes to get to Aeolis Mons. It's about getting closer to Aeolis Mons to get better data about the Gale Crater event. And it all paid off 7 months into the journey to Aeolis Mons. 212 sols after Curiosity started its journey to Aeolis Mons, NASA scientists found an interesting event in one of the 5 high-resolution pictures that Curiosity sent to Earth each sol. A sol, by the way, is equivalent to about 1 day and 39 minutes. More on that later. Normally, around 100 to 1,000 images are transmitted to Earth each sol from Curiosity via the Mars Reconnaissance Orbiter. But with it gone, Curiosity can only send back directly to Earth 2 to 10 images a day. But one of those images caught this. It looks like a small boulder that just hit the ground. But due to the fact that the impact is already generating a lot of dust before the boulder is destroyed by the ground, tells us that it was moving relatively slow at the time of impact, and definitely subsonic. This rules out boulders coming from space or meteorites. This means that something on Mars caused that boulder to be blasted into the air, and then it simply fell back down to Mars. Only one such impact was detected during Sol 212. No debris or fragment of rocks were detected subsequently. This suggests that the boulder was already loose when it was blasted into the air. This was an odd phenomenon worth stopping for an investigation. To play it safe, NASA let Curiosity stay in place for 7 sols to see if the event would occur again, and if so, where the boulders would land. After the 7 sols were up, NASA decided that it was time to visit the boulder, which by now was nicknamed the Rosetta Hammer. But NASA had to wait for about a month because Mars went into a solar conjunction.